Assalamu alaikum wa rahmatullahi wa barakatuh. Hope you all are doing good. Inshallah, in this session, we will cover the chapter 5, which is about the relational data model and relational database constraints. Today's outline, I will start with the relational model concepts, and then we will talk about relational model constraints and relational database schemas. And lastly, we will cover update operations and dealing with constraints violations. Relational model concepts. So let's go with the first point. The relational model of data is based on the concept of a relation. So from now on, when I say the word relation, I'm referring to tables in a database. And here we will use another term to describe table, which is going to be a relation. So how we can distinguish between a relationship and a relation? If I'm having a relationship between two tables, like one-to-one or one-to-many or many-to-many, I'm going to say a relationship from now on. If I'm going to have a table, I'm going to just say a relation. And that was this is a research that found by Ted Codd. He's a researcher that found a way to describe databases in a mathematical way. It says here in the second point, the strength of the relation approach to the data management comes from the formal foundation, which is, inshallah, we will cover in this presentation, provided by the theory of relations. So a relation, a table, is a mathematical concept based on the ideas of sets. I believe you already covered the sets in math before. So when you have a complete set, and then you have a subset, so that subset belong to that set, and etc. So we already did a couple of operations on sets before. So the concept now we will cover in this presentation. It's going to be around sets and math. We will see some terms and others like annotations that refer to sets. We review the essentials of the formal relation model in this chapter. In practice, there is a standard model based on SQL. This is described in chapters 6 and 7 as a language, which is, inshallah, going to be covered in the coming weeks. Last note here we have in the slide, there are several important differences between the formal model, which inshallah we will cover in this lecture today, and the practical model, which will be covered in the coming weeks in chapter 6 and 7, as we shall see. Informal definition. Informally, a relation looks like a table of values. So when I have a table now, I'm going to say a relation, because now we are following the research that was written by Ted Codd. So a relation is a table. A relation typically contains a set of rows. I told you last time we call them rows, we call them records, we call them instances. So it's a set of rows. Rows, we will call them from now on tuples. So in the formal model, rows are called tuples. So we have informal definition, informal, and formal. When I'm saying formal, it's formal to Ted Codd research. So in Ted Codd research, it's called tuples rather than rows. It's called relation rather than table. It's called attribute rather than columns. Okay. So the data element in each row represent a certain fact. So we know that before, if I'm having a table called a student, every row in that table, it's going to be a fact, like the student first name, last name, the student ID, the student's birth of date, like that's a fact that correspond to a real world entity or a relationship. Now it's a relationship and not a relation, like there is a relationship between maybe two tables about that student table. So in each column, each column has a column header that gives an indicator of the meaning of the data items in that column. For example, if I'm having a column that's called first name, it's not right to put phone numbers in that column. It's not to be accurate. So whenever you have a column, the name is going to indicate what the column is going to consist of. In the formal model, the column header is called an attribute name, or we just call it attribute. Here you can see a figure, but that describes what we just mentioned. So this is how to describe your database or table in a formal way. So here's that's called a relation name, that student table, it's called a relation name. Tuples, which are the rows, and we have attributes that are the columns: name, SSN, home, phone, address, office, phone, age, and GPA. Key of a relation: each row has a value of data item or a set of items that uniquely identifies that row in the table, called the key. And we know that already from previous lectures and labs. So every row in our table is going like, there is an item that makes the column or that makes the row unique. For example, if we have a student table, the student ID or the student ID column, or now we call it attribute, is going to make that table unique. So I can reach to any of the students just going through the IDs. If I want, for example, the student Muhammad, I'll just check his ID. By his ID, I can collect all of his information. That's going to make the table unique. So it's called the key generally, or here formally, it's going to be key. In the student table, SSN is the key. So here's the social number. It's the key for every student. And you can see it's unique. It's not identical to any of them. Okay. Sometimes row IDs or sequential number are assigned as a key to identify the rows in a table. So, you know, sometimes you don't have you don't have any column that are unique. So just imagine you do have your friend's name and you don't have for example, IDs. Okay. So if you don't have anything that is unique in your table, you can create a new column that's going to be just the order. So let's just let me create one. So I can create a new one here. I just call it ID, and that ID it's going to be auto increment. So it's going to start from 0, 1, 2, 3, 4. So you create a column that is going to be just a sequence of numbers, and that's you can make it as a primary key. في حالة إنه ما كان عندك primary key يمديك تسوي لك column جديد وتخلي الكولوم هذا الجديد عبارة عن ترتيب لا يتكرر ويميز كل عنصر عندك. لكن في حالتنا الآن عندنا SSN اللي هي السوشيال نمبر، فهذه تميز الموجودين الطلاب اللي عندي وما يحتاج إني أضيف الكولوم هذا. So sometimes row IDs or sequential numbers are assigned as a key to identify the rows in a table. The schema. So formal definitions. Now we are talking formally, or we're following Ted Cod research and how he defined databases. So first of all, we've got the schema of a relation. So it's denoted like R. Okay, the R here, it's just like relation. So this is the denoted by R, and inside the R you can see A1, A2, A3. That's indication of attributes. So A1 first attribute, A2 second attribute, A3 or AN the attribute N. And we know that from the previous slides, the attribute here means column. So I'm saying here, for example, I'm having here is an example. The R represent the table name. So it's relation is the table. So R, if I want to create a new table that's called customer, so I just put customer, then the parentheses here, and then the attributes. So A1, it's going to be customer ID, customer name, and address, and the phone number. And then I'm just going to close. And this is how I will like define the relation in TED Cod way, or in a formal definition, let's say. Okay. One more thing. Here, what we will present, if you remember from the previous lecture, we talked about physical implementation and conceptual levels. What we will, inshallah, today present, we will talk about it today. It's going to be about the implementation and representational level. So all the points now we were going to mention and how we will express and draw our data, it's going to be in the representation or implementation level. So if you are a designer, admin, administrator, you can follow what we will give you in a way that's going to be easy for you to define the relation, data type, data element. باختصار الشيء اللي راح نسويه اليوم راح يكون بالجزئيه اللي في النص، لا هي في الفيزيك ولا هي بالكونسبشوال، راح تكون implementation level. فالتصاميم اليوم راح نسويها الطريقه اللي راح نعبر فيها عن البيانات راح تساعد الامبلمنتيشن، الناس اللي هم زي الادمن، الداتابيس ادمنستريتور او الديزاينر، انهم يصممون الداتابيس بناء على اللي راح نوفره لهم اليوم. طيب نرجع مره ثانيه للسكيما or a description of relation donated by this way. R is the name of the relation. The attributes of the relation are, and here's an example. So customize a relation name defined over 4 attributes. So cost ID, cost name, and address and phone number. Each attribute has a domain or a set of valid values. So when I say the domain, I'm just saying what I'm expected that attribute to accept. Each column, for example, the custom ID, I'm expecting custom ID to be integer. So I'm not expected at all to have float or double. I'm not expected to have a custom ID which is 1.1978. That's going to be not true or not valid. So a domain is all the values that you are expecting to be there. Customer name, I'm expecting to have characters and spaces. I'm not expecting to see numbers. Okay. In address, I might see some numbers and characters. In phone, I'm expecting number as a type. So domain, it's all the expected values that can be assigned to an attribute. Okay, for example, the domain of cost or cost ID is 6 digits number. So that's going to be as a constraint. So that's going to be 6 digits only. It's not going to exceed, it's not going to be less. A tuple, we also covered that before. A tuple means the rows in a database. So a tuple is an ordered set of values enclosed in an angle bracket. So in order to just demonstrate it in a formal definition, we will use the angle bracket. Here's the angle brackets. We will start and then close as well. Each value is derived from appropriate domain. So again, a tuple is going to be following the attribute. يعني الآن عندي التبل هذا كم راح يكون في قيمة بالمثال الماضي. لو قلنا هنا لو استبعنا المثال الماضي اللي هو الكاستمر اللي تكلمنا قبل شوي فيه، عندي كاستمر اي دي، كاستمر نيم، ادرس اند فون. صحيح، عندي 4 كولوم، فكل تبل او كل رو راح يتبع ال4 كولوم هذه اللي موجوده. فيعني لو عندي مثال على الكاستمر الاول اللي راح اضيفه، هذا اول شيء الكاستمر اي دي اللي هو 6 ديجيتس، بعدها الكاستمر نيم، بعدها الكاستمر ادرس اللي هي 101 مين ستريت اتلانتا، وبعدها الارقام، بعدها عندي كاستمر او الفون نمبر. لاحظ معي انها بدات بالبراكت او الانجل براكت وانتهت بالانجل براكت، وعندي كوما between them. So this is the way you just define a tuple in a formal definition. Okay, this is called a for tuple as it has 4 values. A tuple row in the customer relation, which is this one we just explained, and the relation is a set of such tuples rows. So a relation or a table is a set of rows. الجدول بكل بساطة هو عبارة عن مجموعة من الأصفف، أو بمثل ما الآن نعبر عنها الريليشن اللي هي الجدول، هي عبارة عن مجموعة من التابلز اللي هم الروز. Now let's talk a bit about domain, which we just covered. So we said domain is going to be like a constraint. Here we just define the custom ID to be a 6-digit, and also we are expected to see numbers, not strings. So all expectation about a specific attribute, about a specific column, it will be the domain. So a domain has a logical definition. Example, a US phone numbers are the set of 10 digits phone numbers valid in the US. So this is logically. Again, because it's phone number, I'm expecting to have them as a digit and also 10 digits. As Saudi Arabia, yeah, we have 10 digits for numbers. So 10 digits, it's not going to be less, it's not going to exceed that as well. And that's the logical definition. So no one needs to tell you that. You already know that. So that's logical definition. A domain also has a data type or a format. Again, so when we know that it's a US phone number, we are expecting to have digits and number, but what's the type? What's the format? Do we want them to just like list them as 055 whatever until the end, or we want to have them in parentheses like here? So here we have parentheses, then 3 digits, 3 digit hyphen 3 or 4 digits. Do we want them to have them like to have them in this way, or we just want them to be in a sequence? That depends on the format. Also the data type, we are expecting integers in this case, right? Another example, if you have dates, you can represent dates in different formats. You can represent date that starts with a year, month, day, or day, month, year, as in British, or we can have it as an American with month, day, then years. So different formats also can be, or that's also a part of domain. So in domain, we can define the logical definition, data type or format, and lastly, the attribute name. This is a hint that the attribute name designates the role played by the domain in a relation. And I already explained that. So if I'm having a first name, لو عندي جدول أو عندي column اسمه first name، فأنا أتوقع أن هذا الكولوم بيتخزن فيه دائما الاسم الأول. ما أتوقع أني أشوف فيه أرقام، ولا أتوقع أشوف فيه أرقام جوالات. فدائما الاسم الكولوم يعبر عن ما يحتويه. Used to interpret the meaning of the data elements corresponding to the attribute. Example, the domain data or the domain date may be used to define two attributes, name, invoice date, and payment date with different meanings. So each one of them has its own meaning and has its own data. Also, we will talk about state. And if you remember state from the first lecture, you will be fine. So state, it's the situation of a database in a particular moment, if you remember. So the relation state is a subset of the Cartesian product of the domains of its attributes. المعنى بكل بساطة إنه الستيت هي الحالة اللي زي ما ذكرنا سابقا، الحالة اللي فيها الداتا حقتك في لحظة موجودة الآن، وهي غالبا تكون subset من كل الاحتمالات اللي الدومين يتوقعها. واضح؟ الدومين عندي يتوقع أرقام مثلا من 1 6 أرقام. الست أرقام هذه تبدأ من 0 0 0 0 إلى 9 9 9 9 9 9. 6 أرقام كلها 9. ما بين هذا الرقمين أو ما بين هذه المجموعتين كلها أرقام مسموحة. فالستيت حقتي اللي عندي موجودة الداتابيس اللي هي قطعة من الداتابيس في الوقت الحالي دائما تكون من أو subset من الدومين اللي هو يحتوي على كل الأرقام. فهذه الستيت، تعريف الستيت. Each domain contains a set or the set of all possible values that attribute can take. الدومين فيه كل القيم المحتملة وجودها من 0 0 0 0 0 إلى 9 9 9 9 9. واللي ما بين البين 1 2 3 4 5 كل الأرقام اللي بالنص اللي بين تعتبر احتمالات يحتملها الدومين. فالريليشن ستيت حقتك اللي هي صورة من الداتابيس هي سبست من هذه الاحتمالات، هي جزء من الاحتمالات وليس خارج الجزء. فهي دائما صحيحة وتكون valid لأنها تتبع الكونسترينت اللي تعطيني اياها الدومين. Example attribute customer name is defined over the domain of character strings of a maximum length 25. So this is a formal way to define a state or to define the domain. You put the DOM domain, customer name is a varchar 25 characters. So now you do have the constraint. The role these strings play in the customer relation is that of the name of a customer again. So now because it's called the customer name, I'm expected to see names. I'm not expected to see integers. I'm not expecting to see dates, and it must reflect what the name is. And this is basically the definition of it. Again, the same picture that we've seen already in the previous slide. Basic operation. So we talked previously about, or in the lab, we might just tackle a bit of them quickly. We tackle the insert, a new tuple in a relation, a delete an existing tuple from a relation, and a modify an attribute of an existing tuple. I'll talk about constraint and the remaining part of the slide in the coming or in the next part. So watch the previous, or sorry, the next link that I will upload for you.